So this is the third lecture out of chapter 1. So in this lecture we'll cover this concept of significant figures. So significant figures basically just means if you have a measurement, how many digits in that number count, or how many of them have meaning. So to illustrate the concept, so if we wanted to go in the lab and measure some water out, for example, so we would take a piece of glassware that looks like this. So a glassware that looks like that's called a graduated cylinder. So, so if we take the graduated cylinder on the left, so if I ask you how many milliliters of water is in that cylinder, what would your answer be? So first of all, if you want to read this, you read it from the bottom. So it's curvature like that, and that's what's called a meniscus. So you read from the bottom of the meniscus, and so it hits the side here, which is where the scale is at. So how many milliliters? So if this is in milliliters, so how many milliliters is in that flask? So take a guess. How many would you say? Okay, so if I tell you there is 2.37521 milliliters in that flask, how many of you would agree with me? Well, I'm the instructor, so you have to agree with me, right? Because I'm always right. So hopefully you don't agree with me that could not possibly be right. I could not possibly know the milliliters to 5 decimal places, right? So of these numbers, how many of them are you confident in? Are you confident in the 2? And if so, sir, are you 100% confident or 50% confident? So hopefully, if this scale is true, then hopefully you would be 100% confident that it is definitely 2 point something milliliters. It's not 1 point something or 3 point something, right? So we're 100% confident in that number. Okay, how about the next number? How about 3? Are you 100% confident in that number? And I would hope you would say no. That's kind of a guess, right? That's just how good can you eyeball it. So that is our first guess. So that's our first guess. And so when you make a measurement, the way you should report the number is all of the numbers that you're 100% confident in plus your first guess. So we could say 2.3 milliliters, for example. That would be fine. You could say 2.4 milliliters, for example. That would be fine because we're 100% confident in the 2, but the next number is a guess. If you say 2.9 milliliters, well, technically you have the right number of significant digits, but you're not a very good guesser because it's definitely not 2.9, right? It's somewhere around 2.3 or 2.4 milliliters, or maybe even 2.2 milliliters. Okay, so now if we take the next graduated cylinder on your right, if we do the same thing, how many mils are in that graduated cylinder? So again, we read it from the bottom. So, so now let's see. So this would be 1.1, 2, 3, 4, 5, 6, 7, 8. So it's just above the 0.8. So we could say 2.8. Maybe 2.81 milliliters, for example, right? So using this graduated cylinder on the right, we could report it to more decimal places because we have more confidence in digits. So we're 100% confident in that, right? Hopefully no, it's not 2, it's 1. We're not 100% confident that it's a 2. We're 100% confident that it's a 1, right? So 100% confident that the 1 is correct, and 100% confident that the 2 is correct because you have the scale, and if you drew a perfectly straight line across the bottom of the meniscus and see where it hits the flask at, so if it's hitting it right above the 0.8, then we know it's between 0.8 and 0.9. So so 1.8, 100% confident in the 8. The next number is our first guess. So that's how many digits we could have in this number, right? We could go to 2 decimal places in this case. Okay, so now we're going to take these 2 solutions and we're going to mix them together and pour them into a beaker. So now we mix and pour them in. So what's the volume in the beaker now? So let's see. So if we take so we just pick one of these, it doesn't matter. Go with the 2.3 or go with the 2.4, pick one. So if we go with the 1.81 mil, of course you should have said 1.82 mils, 1.83 mils. That the one is a guess. So again, if you said 1.89, you're not a very good guesser. It's definitely close to the 0.81. Okay, so we'll just say 1.81 mils, and let's say 2.3 mils in the other one. So if we add these two together, so 1, and 4.1. So could we say that there's 4.11 mils in this beaker? And the answer is no, you could not. Because if you report the number like that, what you're telling somebody is that you're 100% confident in this number, and you're 100% confident in that number, and you're telling the person that this is your first guess, which is not true, right? Because you're limiting, when you make measurements, you're limited by the instrument that can give you the most precision or most accuracy in the measurement. So the graduated cylinder on the left can only go to 1 decimal place. So if you would have put 2.4 here instead, so if you would have said 1.81 and 2.4 mils, then now you have now you have 4.2. So what is it? Is it 4.1 or is it 4.2 mil? Well, you don't know for sure, right? Because that number is a guess. So you cannot report the answer as 4.11 mil. You would say 4.1 mil, for example, would be fine. So when you make the measurement, how many decimal places you report the answer to is going to be dependent on the measuring device that will measure to the least amount of decimal places. Okay, so if you are working with these two graduated cylinders in lab and you happen to break one, which one do you want to break? You want to break the one on the left. You want to break this one, right? Why would you want to break that one and not the other one? If you had to break one, because this one is cheaper, right? That's the one that's less expensive. Why is it less expensive? Because you can't make as accurate as measurements with it. Because what does this word mean, graduated cylinder? These are graduations. However many ticks you have, those are the graduations. So something that is more highly graduated is going to be more expensive. Okay, so the rules for determining the number of significant figures in a number, in a measurement. So first of all non-zero numbers always, if it's a number with a decimal point, all non-zero numbers always count. So we would say this has 4 significant figures, right? It's got 4 non-zero numbers, and it's got a decimal point in it. This would have 5 significant figures. This number would have 3 significant figures. So where it becomes trickier is when you have zeros, how to treat the zeros. So terminal zeros at the right of a decimal point always count. All zeros after a decimal point count. So this would have 3 significant figures. So if you write the number like this, 9.00 centimeters, what you're telling somebody is you're 100% confident in the 9, you're 100% confident in that 0, and the first guess is that number at the second decimal point is what you're telling somebody. Okay, so then this would have 5 significant figures, and this would have, so all of these zeros are after a decimal point, and they're after a non-zero number, so they all count. Terminal zeros at the right of a decimal point, and we should also, let's include here after a non-zero number. So all of these zeros count, so 1, 2, 3, 4, 5, 6, so this has 6 significant figures in that number. So what you're telling, basically you're telling somebody is that number right there is your first guess. And you are 100% confident in the other numbers. Okay, so zeros between non-zero numbers with a decimal point always count, so that kind of takes care of that number right there. So both of these zeros count because they're between non-zero numbers, so that would have 4 significant figures. And these zeros count because they're between non-zero numbers, so that would have 5 significant figures. Okay, so leading zeros, so that means zeros at the start of a number. Those never count. So they are simply placeholders. So this would just have 3 significant figures, right? Because these are leading zeros. So leading zeros are going to be all zeros before a non-zero number. So these would be leading zeros, so those don't count. These do, so this would have 4 significant figures, right? These would be leading zeros, those don't count, just these 2 do, so that would have 2 significant figures, right? Okay, and then if you have a number that does not have a decimal point, so terminal zeros in a number without a decimal point may or may not be significant, so it is ambiguous. It's uncertain whether those count or not. So the number of significant figures in this case is ambiguous. To remove the ambiguity, you should write the number in scientific notation. So if you meant for all 3 of these zeros to count, so if you meant for there to be 3 significant figures, then you could write this in scientific notation. So if we presume the decimal point is there and move it 1, 2 places to the left so that it's after the first non-zero number. So 9.00 times 10 squared centimeters would be 3 significant figures, right? If you only intended 2 significant figures, so if this 0 is your first guess, and then you have no clue what the next number is, then you only have 2 significant figures, so 9.0 times, it's still times 10 squared, right? Because it's still got to be 900. So that would be 2 significant figures, and if you only meant to have 1 significant figure, then you would write this as 9 point times 10 squared centimeter. So that way there's only 1 significant figure. Okay, so to illustrate the importance of this, so let's say you want to take a significant other on a date, and you tell the person you're going to pick that person up in 7,135 minutes. I don't know how long that is, I just made up a number. So if you wanted to write this to 4 significant figures, you would say 7.135 times 10 to the third, right? So if the decimal point was there, 1, 2, 3, so 10 to the third. So that would be 4 significant figures. So what are you telling somebody if you do this? You're telling them that 5 is your only guess. You're 100% confident in the 7 and the 1. So 7, 1, 3. So that could be 0. You don't know what the 4th number is, or 7, 1, 3, 9, right? This number here is the first guess, so it could be 0 to 9. So basically that's a 9-minute window, right? If you're only confident in 3 significant figures, then 7.13, or we could round that up to 7.14. So let's say 7.14 times 10 to the 3. But it really doesn't matter because that 4 is a guess anyway, right? If it's only 3 significant figures, then you're not 100% confident in the 4 anyway. So what you're basically telling somebody is 7, 1, that next number. So this 4 could be a 0, you're not 100% confident, and then the 4th number you have absolutely no clue what it is. So here this could be 7,100 all the way to 7, 1, and then the next number could be a 9. So now that's a 90-minute window, right? If you only intended for 2 significant figures, in 7.1 times 10 to the third, so then 7, you're not 100% confident in the 1, so it could be 0. Or it could be 9, right? So now you have a 900-minute window. And if you're only confident to 1 significant figure, then you would just say 7 point times 10 to the third, right? So the significance being how you write a number matters because you're telling somebody information. So if you tell your significant other that you're going to be there in 7.135 times 10 to the third minutes, then you were telling them within a 9-minute window you're going to be there. So if you're outside of that window by 10 minutes, you are late and you're in trouble, right? So if you did not mean to give yourself only a 9-minute window, then you better not report the number like that. You better report the number like that. Then you have an hour and a half window, right? And if you're not even sure if you're going to be there within an hour and a half, then maybe you better report the number like that. And now you have a 900-minute window. So the point being, how you write a number has meaning to anybody who's a scientist, an engineer, a mathematician. Right, those numbers have meanings. So all of the numbers count, are 100% confident in, except the last number, which you're telling the person that's the one I'm guessing at. Okay, so now that you know how to count significant figures, let's do some calculations and keep track of significant figures. So there are two different rules. When you're multiplying and dividing, that has its own rule, and when you're adding and subtracting, that has a different rule. So when you multiply and divide numbers, then the answer will have the same number of significant figures, so that's the key. Significant figures is what you're keeping track of, as the measurement with the least number of significant figures. So here we're multiplying these two numbers. This has 3 significant figures, and this has 4 significant figures. So the answer can have 3 significant figures because you go with the number that has the least number of significant figures. This one has 3, so your answer has to have 3. So if you plug this into a calculator, your calculator tells you the answer is 67.7209, but you can't report the answer like that, because if you report it like that, you're telling somebody you're 100% confident in the 67720 and you're only guessing at the 9, which is not true, right? You can only report this to 3 significant figures, so that 7 is the last number that counts. So, so what you now have to do is round. So the next number after the 7 is less than 5, so you just drop those numbers, right? So this would be 67.7 would be your answer to 3 significant figures, and that would be meters squared if you're keeping track of units, which you should be in this class. Okay, so when you add and subtract, then the rule is different. So the answer will have the same number of decimal places, not significant figures. So now all you have to do is worry about decimal places. So the answer will have the same number of decimal places at the measurement, as the measurement with the least number of decimal places. So if we add these two numbers instead of multiplying them, then this has 2 decimal places. Doesn't matter that it has 3 significant figures, that is irrelevant now. And this has 3 decimal places. So the answer will have 2 decimal places. So if you add these two numbers, the calculator tells you that, and this number has to have 2 decimal places, so the 6 is the last number that counts. And now what you do is round. You look at the next number is 5 or greater, so you have to round up. So this will be 16.57 meters would be the answer, right? So totally different. If you multiply and divide, you had 3 significant figures. If you added and subtracted, you end up with 2 decimal places, so that number would now have 4 significant figures, right? Which is basically the same thing that we did up here. We added these 2 volumes together, and so when we add them together, this number only has 1 decimal place, so your answer can only have 1 decimal place, so we would have to cut it off at 4.2 mils, or here we would have to cut this one off at 4.1 mils, right? Because you can only have 1 decimal place. Okay, so and then lastly, let's take a few more complex examples where you're doing both, or where you're doing multiple operations. So if we do this one, so we multiply 2 numbers and then divide, so the only rule that we have to worry about is this one. You just keep track of significant figures. So here we have 4 significant figures, here we have 3 significant figures, here we have 2 significant figures, so the answer will have 2 significant figures. Okay, so 6.223 times 4.31, and divide that by 2.0, and your calculator tells you 13.410565. But you can only have 2 significant figures, so the last number that counts is that 3. So 13 point is the way you would write that, or you could write that in scientific notation, 1.3 times 10 to the 1, right? Either would be acceptable. Okay, and this next problem, you're just adding and subtracting, so the only rule that matters is number 2 here. You just keep track of decimal places. So this number has 3 decimal. This number has 2 decimal, and this number has 4 decimal, so your answer will have 2 decimal places. So 1.111 minus 0.25 plus 17.3555. Calculator tells you, if I did my math right, 18.2165, and it can have 2 decimal places, so the last number that counts is that 1, and the next number is 5 or greater, so you round up, so this would be 18.22 would be the answer there. Okay, so this next one's a little bit more complex because now we're doing multiplication, division, addition, and subtraction. So now you have to remember your order of operations. So first you do what's in parentheses, right? And we're going to do the multiplication and division, and then we'll do the addition and subtraction last. So let's just take these two numbers and multiply them. So 6.75 times 8.221. So let's keep everything else. So that gives you 55.49175, and then we're going to divide that in a minute by 2.711, and then plus the 202.20. Okay, so now what we want to do is we want to figure out, in that we did that one multiplication, what is the last number that counts? So we're not going to round, we're going to keep all of the numbers in our calculator. We just want to know what's the last one that counts. So this has 3 significant figures, and this has 4 significant figures, so your answer has to have 3 significant figures. So the last number that counts is that 4. So I'm just going to circle it so that we keep track of it. Because now that tells us this number has 1 decimal place, right? But we're not going to round, we're going to keep all of those digits in our calculator. And now we're going to do the last operation. So this has 1 decimal place and it has 3 significant figures, right? So 3 significant figures. So if we were doing multiplying and dividing, which we are, we're going to divide now, so we have to know how many significant figures that has. If we were just adding and subtracting at this point, then we would have to be conscious that it has 1 decimal place, because the 9175 doesn't count, right? Okay, so now we're going to divide. So take that number, divide it by 2.711, and we get 20.4691074. Again, we don't round until the very end, otherwise you end up with a rounding error. Okay, so now this number had 3 on top, had 3 significant figures. The number on bottom had 4 significant figures, so your answer can only have 3 significant figures, which means that is the last number that counts. Okay, so this has 1 decimal. Right, because the top number had 3 significant figures, the bottom had 4, so when we divide them, our answer can only have 3 significant figures, so 20.4 is where we would cut that number off if that was our answer, but we're not done calculating yet, so we don't round. We just keep all the answers. We just make a mental note that the last number that counts is that 4. So it has 1 decimal place, which is what matters now, because now we're doing addition and subtraction. So now we take 47.552 and subtract the 20.4691074 and add 202.20, and your calculator tells you 229.2828927. Okay, so now all we did is add and subtract, so what matters is decimal places. So this has 3 decimal, this has 2 decimal, and the middle number has 1 decimal, so your answer has 1 decimal, so the last number that counts is that 2, 1 decimal point. So the next number is 5 or greater, so we have to round up, so 229.3 would be your answer there, right? Okay, last problem. So we want to do all this multiplication and division first and do the additions last. So 32.72 times 2.5 divided by 9.1 gives you 8.989010989. And then we're going to add 100.3 to that. So, but first, before we do the addition, we have to figure out in this number that we just calculated, what is the last number that counts? Well, this has two significant figures, this has three significant figures in the middle, and the first one has four significant figures, so your answer can only have two significant figures. So the last number that counts is that 9, the first 9. So 1 decimal. And this has 1 decimal. So when we add these two numbers together, so 109.289011 has to have 1 decimal. So the last number that counts is that 2. Next number is an 8, so we're going to round up. So 109.3 meters. This would be your answer. Okay, so hopefully that makes sense. And we will stop there.